Hi, this is Crystal Higgins, and I'd like to talk to you about the Project 3 report that I worked on along with Muhammad Usman and Monica Varala. Our project is about time series analysis using RStudio. So, time series analysis involves analyzing a collection of data across specific intervals of time to gain an understanding about the data and forecast future data. So the first thing that we did was choose a data set, and we chose that from the time series data library, which is available from GitHub. So the first thing we did is install the TSDL package, and then we loaded it into RStudio. And this particular data library has 648 data sets to choose from. We chose to use data set number 224, which is described as the annual immigration into the United States recorded in thousands from the years 1820 to 1962. And this data, this frequency number here indicates that this is a yearly collection of data. So every number is for a different year. The next step is reading the time series data. So we use the TS command to enter it into, to redirect it into an object called immigration. And as we did that, the command, we divided it by 10, the data by 10, so that when we graphed it later on or we plotted it, it would show up in regular numbers as opposed to exponential numbers, just a little more human readable. And then we passed in the parameter frequency of 1, meaning it's yearly data, and a start value of the year 1820. And so issuing that TS command actually gets it into a time series format. And now it's all in the object immigration for use so that we can plot it. So the next step is to plot it using the plot.ts command. And we also passed in labels for the year and then immigration and giving the units of measurement, 10,000s. And this is the graph of what happened to immigration over time. So the next step would be decomposing the time series. And decomposing basically means separating out the trend component from the irregular component so that you're more able to see what actually has happened over time. And so our particular data set is non-seasonal and fits the additive model. So the next, so we could apply a smoothing method. So the next step would be using the simple moving average function to be able to smooth the data. And so a parameter that you must send in to the SMA function is order or span, the span of time that you want to smooth the data. So we started out with an average of 3 to see how this affected things. And you can see the script or the function that we used, SMA, and then we put it into this object immigration SMA3. And we plotted the data to see what it looked like. And using this, it smoothed the data a little bit, but there's still some pretty sharp fluctuations in the data, especially around the year 1880, you can see here, and around 1910, some pretty sharp fluctuations. So we added a higher number, let's add 10 for the smoothing to see what that does to the data. And that seemed to smooth it out pretty well so that the general trend, so that we could see that the general trend was an increase in immigration from 1820 to an overall peak around 1911. So in general, it just kept going up to 1911. And then from that point on, there was a decrease in immigration generally, and then a sharp decline around 1940 where it bottomed out. And then again after that, it generally went up. And so at this point, I'll let Usman talk about the rest of our report. All right, thank you.
Hello everyone, this is Mohammad Usman and my group member Crystal has introduced us in the beginning, and she has gone through the pre-processing steps of our project, like what's the goal of our project and what we are going to do. So after all the selecting time series data, plotting time series, additive model, decomposing time series, trend from irregular season, non-season. After all these steps, the main steps of this, while predicting any time series data, it's a ARIMA model. So ARIMA is an auto-regressive integrated moving average. So this is used to analyze any statistical model or any data to anticipate the future trend. So in ARIMA, we have the parameters, which is we have three parameters which need to be considered while applying the ARIMA model on any data set. So three parameters are P, D, and Q. So P is the number of lag perception in the model. D, the number of time that the raw perception or difference, also known as degree of difference in lag, when you need to differentiate the data from the past value to the present value or the continuous value. Lastly, Q, the size of moving average window. After that, after we use this line immigration, like immigration is the name of our data set, so we are differentiating immigration with the value of 1. So we have here with the x-axis and the y-axis. So this is the final outcome after applying the differences on a time series data. So after that, the main part to apply the regression to predict the data is selecting the ARIMA model. So there are two ways of selecting ARIMA model. The one is to select manually while considering the three parameters which I discussed before, the P, D, and Q. And there is another method that is called auto ARIMA. So in auto ARIMA, it will automatically select the best fit model according to the time series of data. So so here in the down, we use auto ARIMA on the library. 224 is the our dataset number in the TSDL library. So when we apply the auto ARIMA function on the datasets, so it returns us the best fit ARIMA model, and I mean the value of P, D, and Q. So in our case, it's 0, 1, 2. It returns automatically. So what's the value you are going to use in the final outcome? So now it's time to forecast the value. Like we have the ARIMA model, we have the value of the three parameters P, D, and Q. So we need to forecast. So for forecasting the data, we have the library called forecast, and using this library, you pass the ARIMA model in the forecast function, and it will forecast the value. Like here we are using h is equal to 5, so it's gonna predict the next 5 year the value, and after forecasting, so it is giving us the predicted value for the next 5 years. So the known data is till 1962, and we predicted for the next 5 years, that is 1963 and 1967, between these 2 years. So here you can clearly see the predicted values, and we plot this predicted values using the plot forecast function. After plotting the forecast function in the highlighted area, you can clearly see that these are the forecasted value. So till here, we have a known value, and after 1962, we have a forecasted value. So as from the graph, you can see that the immigration into the United States slightly decreased till 1963 and remains constant till 1967. This, in the end, um, this data set or this prediction on this data set can be used by many industry, many airlines, hotels, or any businesses to develop the business plans accordingly. For example, uh, there's a airlines business, so they can develop their plans, the business plans for the next 5 years by using the regression by applying regression on the past data. So it will help the businesses. It is not accurate, but it's close to accurate because predictions cannot be so accurate. So this is what we achieve throughout our project. We use the data set, we use the known value, we apply auto regression on it, we use ARIMA model to find the best fit model, and we predicted the next 5 years of values.